in the last class, we printed the values in the linked list, isn't it? So today, let's move to the next question. The next question states that the function add node takes the linked list and pointers as parameters, and then takes input, the data to be added to the end of the linked list. I repeat, the function add node takes the linked list and pointers as parameters, then takes as input the data to be added to the end of the linked list. How many parameters does this require? There are two parameters, there are three parameters, which is the linked list and the two pointers, isn't it? As parameters. So that means that when I write my code for the add function, add node, then I have def add node, then the linked list as the parameter. What are the two pointers? Can you remember the two pointers? They are the what? The start pointer and the empty list. Those are the 2 pointers. Is that understood? That must be passed as parameters. Understood, everyone? So I have the start and the empty. Is that understood? Yeah. Now, but the aim of this is to add value to the linked list, isn't it? We want to add a value to the linked list. Now, to add a value to the linked list, we need that value. That was why it says that, back to the question, then takes as input the data to be added. Takes as input the data to be added. So that means you have to request input from the user, right? So how many values is expected to be requested for the user to be passed by the user? One value. That's the data, isn't it? So that means I should have user is equal to input, enter the data to add to the linked list. Is that understood, everyone? Okay, good. So what is now the protocol? The process of adding data. We cannot just write the code. We need to go back to the table. Now, this is the process of adding the data to the next node. Number one is you have to check if there's an empty space in the linked list. Is there an empty space? How do you know if there's an empty space? Number one, you have to check the value of the empty list. If it is pointing to a valid index in this memory location. Okay, now is this pointing to a valid index? How do you know? You have to check if the empty list is less than or equal to 9 or greater than or equal to 0. So that means if empty list is pointing as index 0, that means there's an empty list, that index is empty. 1, 2, 3, 4, any value from 0, it is empty. If it is also 9, okay, it is empty, but anything above 9, it is not empty because it is not pointing at a valid index. So it will be greater than or equal to 0 and less than or equal to 9. So at the same time, both must be true. So if this is true, if both conditions are true, so that means there is a space in this linked list that we can add a value. That is number one. So number one, check if. So you check if there's an empty space in the linked list. Now, if there's no empty space, of course, that means you cannot add. It is either the linked list is full or the linked list does not exist. That's number one. Number two, if there's an empty space, then you add that value to that empty space. Okay, you add that value to that empty space. That is the protocol. So let's take, for example, we want to add a value of -1. -1 is the data value we want to add. Okay, now what is the value for the empty space? The value for the empty space is 5. That means space 5 is empty. That is what it means. Index 5 is empty. The value I want to add to index 5 is -1. Then that means I have to add -1 to that index. So the previous value as that position has been replaced by -1. Is that understood? That is the number. That is the second thing to do. Then after adding the value, you have to make sure it is now the last value, because you are adding the value to the end of the list according to the question. Okay, if you go back to the question says that takes as input data to be added to the end of the linked list. So that value is supposed to be added to the end. So that means if you add that value is the last value. If the value is the last value, then the value for next node cannot be 6. If it is 6, that implies that it is pointing to index 6. So that means it's not the last value, which is wrong. So that means you have to change this to -1 as well. So it becomes the last value. Is that understood? So if this becomes the last value, then we are still going to have another problem, because this index 3 was the previous last value, because the next node was what? Was -1. So we cannot have two last values. Is that understood? So that means we have to make sure that the previous index, that is the index, the previous last value, the previous last value, which the next node is -1, will now point to the new last value. Then this -1 needs to be changed to 5. Is that understood? Now, if it is changed to 5, we are not yet done. There's one thing left. The value for empty list is still 5. That means if I want to add another value, it is still added to index 5. Index 5 is no more free. So that means index 5, this empty list needs to change from index 5 to what? Oh, I have lost the value. It should have changed to index 6. Remember, 6 was the next node. Not because 6 is the next value, is the next index, but 6 is the value of the next node. So this should change to index 6. So that means that you must keep this, you must have update your pointers before you now change this next node to -1, so you don't lose that value, the previous value. I hope this is understood. So what is now the step for doing this? Okay, what is the step for doing it? Number 1, like I said, check if there's an empty space in the linked list. That is the first thing. Number 2 is now add that value, add the new value to the what? To the empty list index. That if there's an empty space, is that understood? Add the value to an empty list index. So let's add the value. So the value empty list is 5, so we add the value -1. Is that understood? So after adding the value, of course, we cannot change the index yet, the value for the next node yet. The reason is because so that we don't lose that value. Is that understood? So that we don't lose that value. What is the next thing to do? We are supposed to find the previous last value. So number 3, find the previous last value. How do you find the previous last value? Why do we need? Why? So that we can what? So that we can change the value of the next pointer to point to the new last value. That is the reason we need to find the last value. Okay, but according to this, in this work, the value of the previous last value cannot be seen, because this is an abstract data type. Don't forget, we cannot just see it. Because the table is seen does not mean we can know it. So that means we have to navigate to the linked list to find the index of the previous last value. So how do we navigate through the linked list? By starting from where? From the start pointer. Is that understood? So we need to start from the last pointer, the start pointer, navigate until we find the index of the last value. I hope you can understand that now. So let us do that. So how do we do that? Number 4 now. Let me write it here. Number 4, we navigate through. So that means we have to start from the start pointer. So we navigate through the linked list to find the index of the previous last value. Okay. Now let's start from the last pointer, the start pointer rather. The value for the start pointer is 0, so we start at index 0. Okay. Now the next node is now the new starting point. Okay. The next node is what? Is 1. Then we go to what? Index 1. The next node is what? Is 4. Then we go to index 4. The next node is 2. Then we go to index 2. The next node is 7. Okay. Then we go to index 7. The next node is 3. Then we go to index 3. The value of the next node is -1. So that means the index of the previous last value is 3. I hope that is understood. So we have now known the index of the previous last value. Then we will now change the value of the next node to what? To the value of the next node of the new last value. What do I mean? The value of next node of the new last value is 6. Isn't it? Sorry. No, that was a mistake. We change the value of the next node to the value of the empty list, rather. Okay, so the index of the previous last value is 3. So that means we change the value of the next node at index 3 to what? To 5. So that this is now 5, pointing to the new last value. Is that understood? After doing that, then number 5 step is now to do what? Is now to change the value of empty list. The value of empty list should now be equal to 6. That is the new empty list. Okay, then we keep it to a certain variable. Then the last thing is now to change the next node from what? From 6 to what? -1. So that this now becomes -1. I hope this is well understood. So that is the process. So if the process is now understood, then it is easy for us to write that code since the process is understood. Okay, so let us now write the code in Visual Studio Code. So back to the Python code. So don't forget, if you want to write this code, you have to understand, you have to follow your analysis, the process of adding before the code is written. Okay, now, like I said, you have to check if there is an empty space in the linked list. And how? By checking if empty list is greater than or equal to 0 and less than or equal to 9. So that means we have to check if empty is greater than or equal to 0 and empty is less than or equal to 9, if it is between 0 and 9. Okay, so if this is valid, what is the next thing to do? Add the new value to the empty list index. And don't forget that if you want to add the new value to the empty list, the new value is the user input value. And the linked list is saved in an array. Can you remember? In the linked list array. And this linked list array can only accept, or the only data type that can be saved in this linked list array is the node object. Okay, is a node object. So that means we need to create an instance of the class node we need to have an instance of the class node to create that object. Okay, then we write that new object, okay, is equal to node. Node is requiring what? 2 parameters, the data and the next pointer. Okay, so what is the value for data user? What is the next pointer? It should be -1. The next pointer is because it should now be the last value. Is that understood? But don't forget, we have not added it to this table yet. We only created an instance. We only instantiated the what? The class. We only created an object. It has not yet been added. Now, according to this step, it says add the new value to the empty list index. If you add the new value, okay, let us add the new value. Then that should be linked list of what? Of empty is equal to new object. If you do this, then you will lose the what? The value of the next node, which was 6, because that means it has been replaced totally. Is that understood? So let me clean this so that we can understand it properly. So what I have just done is I have now added, if the user input is -1, for example, that means I have changed this value from -1. I have also changed this value from -1. So can you see I have lost that value of 6? So it will be difficult to now update the empty value to be what? To be 6. That will be difficult. So it is either I save that value to a variable before adding the value to the array. So I cannot just add because I will lose that value. So the first thing is not just to add. Okay, that is not the first thing. So we cannot add yet. So let's add at the end. That was why you see at the end is when we updated the what? The value of the empty list. It was at the end. Is that understood? So let's leave that for now. Don't let us add yet. So it now says that find the previous last value. So by finding what? By finding the index. Is that understood? So to find the previous last value, don't forget that we want to find the index so that we can change the value of the next node to what? To this empty list. So we cannot even change empty list yet. We cannot change it yet. Is that understood? Because we have to change this value to 5 before we now change empty list from 5 to 6. Is that understood? So let us now find the previous last value by finding the what? By finding the index. Once the index is found, then we can know the value of the next node. Is that understood? So let's find the index. Like I told you, if you want to find the index, you navigate through the linked list by starting from what? From the start pointer, isn't it? So let's do that. So that means we have to write that while start is not equal to -1. So that means we navigate through while start is not equal to until we get to what? Until we get to -1. Because it is until the value of the next node is -1 that we have gotten to the last value, isn't it? So while start is not equal to -1, then I have to write that start is equal to the linked list of start dot next node. Okay, now what have I done? This line of code will return the value of the next node at that start position. Is that understood? So let us illustrate that. We need to illustrate that. We need to understand properly so that we don't just memorize. Okay. Now, what is the value for start? 0. Is the value for start -1? No. That means this condition is true. Is that understood? This condition is what? Is true. If this condition is true, don't forget the value for start is 0, isn't it? So the linked list of 0 dot that is we return the next node at position 0. And next node at position 0 is 1. Is that understood? That means the value of start is now 1. The value of start is now 1. It goes back to this while loop to check if it is not -1. It is true, it is not false. Since it is true, it now take the linked list at position 1 dot next node. At position 1 dot next node, what is the value for that? It is 4. That means the new value for start is now 4. Is that understood? Now that it is 4, so it now go back to this while loop again. Don't forget the loop will continue to loop. Now, why start is not equal to -1? This value is what? Is true. That means that is now what? The linked list of 4. Don't forget the previous value for start is 4. The linked list of 4 dot next node, isn't it? So the linked list of 4 dot next node is what? Is 2. That means the new value for start is now 2. Is that understood? So now that the new value for start is 2, so why start is not equal to -1? Of course it is 2. It now takes what? The linked list at position 2 dot next node. So linked list of 2 dot next node, the value is what? Is 7. Okay, now that means the new value for start is now 7. So since the new value for start is now 7, it goes back to the while loop to check if it is not -1. Of course it is true. So that means that will now be what? The linked list of 7 dot next node. Is that understood? So linked list of 7 dot next node is what? Is 3. That means the new value for start is now 3. Is that understood? The new value for start is now 3. So why start is not equal to -1? Of course it is true. So that will now be the linked list of 3 dot next node. So the linked list of 3 dot next node, of course, is what? Is -1. That means the new value for start is now -1. So it gets to this while loop and leaves. What is the problem? Our interest is not the value for the next node. Our interest is to return the index 3, is to return the index and not -1. So the previous value of start is now -1 and not 3. That means I have lost the 3. I am not supposed to lose that 3. So to prevent that, let me now create a new variable. Let's call it next is equal to what? Is equal to start. So that by the time the value of start was 7, by the time the value of start was 7, okay, when the value of start was 7, so value of start is 7. So why start is not equal to -1, that value, that is true, isn't it? So the value of next is now 7, because value of start was 7, next is 7. So that means the linked list of 7 dot next node, the linked list of 7 dot next node is 3. That means start is now 3. Since start is now 3, it now goes back here and say why start is not equal to -1. Of course, start is 3. So the value of next is now equal to 3. That means start is now equal to linked list of start dot next node. The linked list of 3 dot next node is what? Is -1, isn't it? So the linked list of 3 dot next node is -1. That means start is now -1. When you come back to this while loop, -1 is now false. It just leaves this loop. When it left the loop, don't forget next was 3. So I have gotten the index. The index is not lost. I hope this is understood. So this is the line of code that we use to return the value of the previous last element index. The index of the previous last element is now equal to next. I hope that is well understood. Now, since I have gotten the index, which is 3, what am I supposed to do? I am supposed to change the value of the next node at that index to what? To the empty list, isn't it? Change the value of the next node at that index to the empty list. That is the next thing. So how do I do that? So that means that I'm now out of the while loop. Is that understood? So that means that the value of linked list at that index outside of the while loop, after the loop is done, is equal to what? Is equal to empty. The value of next node. So that should be dot next node. Yeah. So because this is the value at, this is array 3, that is linked list 3. The next node is now equal to empty. Don't forget, empty was still equal to, is still equal to 5. Is that understood? Empty is equal to 5. So the value is now 5 and no more 3. Excuse me. So now that the value is now 5, what is now the next thing according? That's why you have to write down the process so you don't forget what you are doing. If you don't write down the process, it is most likely you're going to forget what you are doing. So after changing the value of this, so that means that this is no longer -1. The value of this is no longer what? Is no longer -1. It is now 5, pointing to this. Don't forget, I have not added the value yet. Is that understood? Pointing to this. So now the next thing is now to change the value of if you change the value of the empty list. So that, don't forget, you have not added the value. If you change the value of the empty list, you are going to be in trouble. Is that understood? Because if you change the value of the empty list and you now add the value to the position of empty list, you are going to add the value here. So the next thing, let me take the value of this next node and put it to another variable so I can keep it. Is that understood? So let me now write it this way, that the new next node, is that understood? The new next node, is it the new next node? No, the new empty list. Yeah, the new empty list. The new empty list. The new empty is equal to this value at the next node value of the empty, isn't it? So that should be linked list empty dot next node. I hope this is understood. So that means that I have created a value called new empty, which is equal to the linked list of 5 dot next node. So this 6 now is now the value of the empty. Don't forget, I have not changed the value of the empty list. The value of the empty list is still 5. I only created a new variable to keep this value. I hope you understand that. So after doing that, then I can now add my new instance that I have created. I can now add it here at this value of the empty, which is 5. So that means I can now return back this code and say it is linked list of empty is equal to new object. So that means that linked list of 5 is equal to the input value from the user, comma what, comma -1 has been added. So now that that has been added, then I will now change the value of the empty list to be equal to what? To be equal to 6, which is because this is no longer 6. This is now -1. Is that understood? But I have saved the previous 6 to a new variable. Then I will now make the empty list to be equal to that. Is that understood? So that means it's the empty will now be equal to new empty. I hope this is well understood. So if this is well understood, you can write in the comment section if you don't understand. So let's now attempt to add a new value. Let's run this code to attempt, let's dry run this code to have the analysis of adding a new value after adding the previous value. So what do I mean? If the previous user input was -1, so that means the value here is now -1. This is -1, isn't it? So this is 5, and this is what? Empty list value is now 6, isn't it? So let's follow that code to see if it works to add a new value. Okay, now very simple. Let us add a new value. Let's say we want to add a value 7. We want to add a value 7. So according to this code, now we won't follow our analysis, we have to follow the code. Okay, now according to this code, the code says if empty list is greater than or equal to 0 and less than or equal to 9. Is that valid? Yes, the value is 6. It is valid. Now it now says why start is not new object is node user comma -1. That means the new object is what? Is 7 comma -1. This is a new object, but it is not yet added. It is just the new object. Okay. Why start is not equal to -1? What is the value for start? The value for start is 0. It is not equal to -1. It is valid. So this is true. Next is equal to start. So the value for next is now equal to 0, isn't it? Now that the value for next is 0, it now says that start is equal to linked list of 0 dot next node. I want to change the value of start to the linked list of 0 dot. So what the linked list of 0 dot next node is what? Is 1. So what is the value for start now? The value for start is 1. So it goes back to this while loop and check if it's not -1. Is it -1? No. So no. So that means this the condition is true. The value for next is now equal to 1 and not 0. Okay, the value for next is now 1. Now next is now 1. So linked list of 1 dot next node. The linked list of 1 dot next node is what? Is 4. That means the value for start is now 4. So why start is not equal to 1? That means the value for start is not equal to 1. It is true. Next is equal to start. The value for next is now 4. Okay, so linked list of 4 dot next node. Linked list of 4 dot next node is what? Is 2. Is that understood? Since that is 2, then it goes back again. Is that equal to -1? No. So next is now equal to 2. Okay, the value for next is equal to 2. Since the value for next is 2, that means that linked list of 2 dot next node. So linked list of 2 dot next node is what? Is 7. Of course, this is true again. The value for next is now 7. The value of next is now 7. So linked list of 7 dot next node. Linked list of 7 dot next node is now 3. Okay. Now, of course, that is not -1. The value for next is now 3. The value for next is now 3. So linked list of 3 dot next node. Linked list of 3 dot next node is what? Is 5. No more 3. Is now 5. Is that understood? So the value for next is yet not -1. So the value for start is not yet -1. So this condition is true. So the value for next is now what? Is now 5 rather. Oh, I've written it already. The value for next is now 5. So the linked list of 5 dot next node. The linked list of 5 is now what? Is now -1. So that is the end of the list. So don't forget that the value for next is already 5. That means the linked list of 5 dot next node is equal to empty. So the linked list of 5 dot next node, that value of this next node has been changed from -1 to be equal to empty. What is the value for empty? 6. It is now 6. Don't forget the value for empty was 6. It is now 6. I hope that is understood. Now it now says that new empty is equal to linked list of empty dot next node. The linked list of 6, which is linked list of empty dot next node, is what? Is 8. That means new empty, the new empty will now be equal to what? 8, which is now this value, will be equal to 8. It now says that linked list of empty is equal to new object. So linked list of 6 is equal to new. So what is the new object? 7 minus 1. The value has been changed from 8 to what? -1. And lastly, empty is equal to new empty. So the value for empty list is now equal to what? Is now equal to 8 and no more 6. So I hope this is well understood. So that is the code for add node. So let's go back to the question. So the question says return true if you could add. If you could not add, return what? False. Isn't it? So that's what the question says. So that means after adding, then I should return true. Okay. So if I cannot add, that means that condition is true. It's not compulsory, right? Else, then you return false. If you couldn't add, you return false. So that is the end for add node. Now the next question. That is 7 marks. It was 7 marks because of the thinking, not because of the length of code. The length of code is so short. It is the time required to think and analyze that makes it 7 marks, not because of the length. So you are not expected to write, don't say because it is 7 marks, you are expecting to write 1,000 or 500 lines of code or 25 lines of code. No, it is because of the time you are required to think. Now, the question now states, the next question states that call add node. Edit the main program to call add node. So let's go back to the main program. Okay, edit the main program to call add node. And add node, you have to pass how many parameter? 2 parameter, which is the linked list. 3 parameter, the linked list start and empty, isn't it? So that will be the linked list start pointer and the empty list. So these are the 3 parameters you must pass. Don't forget it's going to return a variable, right? So value is going to return either true or false. Okay, good. It says output an appropriate message depending on the result returned. So I've saved the value returned to value. Then I write if value is equal to true, then I can write print node added successfully. Okay. Now else, that is if it is false, print no empty node space or node not added. Okay. So that has been, so it now says call output node twice. One before calling add node and one after calling add node. So that means before calling add node, output node has been called, isn't it? After calling out node, then I can also call output node again. I hope this is well understood. So I have called it once there, I have called it another one here. So you see, call it twice, one before and one after. So test your program by inputting 5. Take your screenshot of the output. So let's input data value 5. Okay. Now, don't forget to call the main function. So run your code. So this was the previous. So the value to add is 5. Enter. Now 5 has now been added to the end of the list. It is now 1, 5, 2, 6, 56, 7, 5. Okay. So I hope this is well understood. So if there is any question, just ask your question in the comment section. Thank you. So before I go, let me remind you, I have used object-oriented programming to solve this problem. I have also illustrated how to use one 2D array. I have also illustrated how to use two 1D array. So as an assignment, try and practice how to use one 2D array or two 1D array instead of using object-oriented programming. It is the same flow, the same protocol, the same process. Okay? Thank you for your time.